when we have talked about self-information and entropy of, uh, of a message sent having multiple number of bits sent over a transmission for a self message or a single message or a set of message, but we haven't talked about what if suppose two messages are sent over a medium, and what will be their joint probability, what will be the mutual information they'll be transmitting over the medium. Let's consider probability of yj slash xj is known as forward transition probabilities, as they move forward from as one symbol is being transmitted over the medium with a probability of 1 by 2, and what will be the probability that the same symbol will be received at the receiver. So in that scenario, if the same probability is not received at the receiver, we get an error probabilities, which is P of yj slash xi as I is not equals to j. Mutual information received per symbol I, xi and by 2 is equals to log to the base 2 pyj slash xi divided by pxi bits. That is the information sent over a symbol. Okay. For mutual information between two different symbols. One that is transmitted and what is received. The term given the amount of information transferred when xi is transmitted and yi is received. If yj is unrelated to xi, in that scenario, pxi is not dependent on yj, hence it will only be the independent probability of xi. You can break. This is for the individual symbol. You must be saying that, yeah, what is self-information per symbol. But if you take a cumulative, considering all the messages contained in that variable set of x and y, then it is given by this formula. An additional joint probability is multiplied in the whole formula. The average amount of source information gained per received symbol. You can break the joint probabilities in this formula. Okay, so moving forward, the final result is the self-inform or the mutual information is equals to the entropy of x minus entropy of x upon y. Now this entropy that the y is transmitted, the x is transmitted such that the y is received, is the information lost over noisy signal. That's why we deduct this information from the entropy, whole entropy, and whatever we get is the self or the mutual information. This is joint probability and this is conditional probability. Okay. Earlier we have other formula for mutual information. Now if you consider just entropy bits per symbol, then this is the formula. The average information transferred per symbol equals the source entropy minus the lost information, as we have already known. Now for a bisymmetric channel, if we see that our crossover frequency is alpha and forward transition probabilities is 1 minus alpha, and the probabilities of the respective transmitted messages is p and 1 minus p. For a bisymmetric, that means two messages are transmitted. We can get the probability of error by the alpha itself. Okay, or we wish to calculate that if that particular symbol will reach the receiver or not, there's this other formula. Now the discrete channel capacity. Discrete channel capacity, what is actual the channel capacity? Is the maximum, it's a mutual information that can be transmitted. Okay, the maximum amount of information transferred per channel symbol. The maximum rate of information per capacity per unit of time. C is S into C of S. The fundamental